Hi, Michael. This is Dr. Pingle. I wanted to show you a little bit about some of the techniques I was talking about to highlight the elevation of your data set. To do that, I brought in an eTopo1 data set. This is a global elevation data set that includes bathymetry. And you can see that it goes from about negative 10,800 meters up to 8,300 meters or so. But it does so during this using a black to white color scheme. The problem with using this for elevation is it works okay, but of course there are lots of other ways to do this. So if you go into symbology, just an easy thing to do would be to pick something that may be a little bit more terrain sensitive. So there are a lot of elevation variants that you could use, and that would start to do a pretty good job here. But what we're not seeing here is sort of so this is what we would call a hypsometric tint. What you're not getting here is any of the sense of the slopes. So kind of a nice thing to do here is to run just a quick slope layer, and you can do that here if you wanted to. In fact, quick jump here. This data set, for whatever reason, doesn't have a coordinate system attached to it, so I'm going to do that real quick. Not such an unusual problem, but it only takes a second to fix. Great. So this is actually correct. And we could change our view here so that it's not so obnoxious. There we go. So, so we could use a standard slope tool to do that. You would want to just run it pretty much as is, as long as you have your coordinate system defined. It can be nice sometimes to define this as geodesic, and in particular this data set, it wouldn't matter for your LiDAR data because it's going to be in a projection system that planar would work fine. I assume it's in UTM or something. But we could run this like so. I'll pause here while it runs. It really shouldn't take too terribly long, but no sense in watching a status bar go by. Okay, so this has calculated a slope layer here. By default, this actually attaches a kind of a brown tint to this, which I'm not a huge fan of. I wanted to show you another variant of this that I actually like quite a bit better. So you've probably seen things like the Hillshade tool would be another way to do that. You could run this just so. But the tool that I like quite a bit better is in the raster functions box. And if you go down to the bottom of it, there's a surface. And there are two tools here that are quite useful. One is shaded relief. So you can literally just run this straight on here. It's going to have a pretty reasonable color ramp. And then I happen to like the multi-directional Hillshade. We'll talk about this in a second. But you could just run this with the standard settings, and you'd create a new layer, and you would get something, modestly reasonable. What I want to do here, actually, that didn't look very good at all. What I wanted to do is focus on the Hillshade here. So if you take this one and do multi-directional, I have a sense that it's probably not behaving with respect to the coordinates here. So the Z factor is probably almost certainly off by a good margin here. I was hoping that this tool would have factored that in like the slope tool now does, but it didn't. That's fine. So a little deeper dive than I intended to do here, but the multi-directional, you'd have to set a Z factor here to sort of bring out these details the way that you like them. In fact, this is probably actually correct on that scale. But anyway, you could bump this up. Oftentimes, a smaller factor here is going to be sufficient. So here we're starting to see some of those come in. But you can bump that up to whatever you like. There's no correct number here. It's kind of all done by eye. So you can sort of see what starts to make sense. So this looks fine to me. You could probably bring out a little bit more detail here if you wanted to, but let's not belabor the point. What I wanted to do here was show you how to combine these two layers. So you've got your regular layer that's tinted the way you like it. You have this layer the way you like it. And this is actually just was added fairly recently. There's a layer blend option here. And so if you do a darkening mode of multiply, you can really add a lot of depth to this image. Let's add in your data. So I'm going to bring in just a little bit. I'll turn these off. So this is your island right here. It looks like this was probably done fine. Low elevations as far as I can tell. If you use the shaded relief here, because your values are a little bit more, the horizontal units are in meters and your vertical units are in meters. Unlike the eTopo 1 global data set where the horizontal data was in, fractions of a degree and your vertical was in meters. So two different sort of measurements. This should work a little bit better. So again, I happen to like the multi-directional. You could play with the Z factor. We'll see how this looks by default. But what you get when you do that is a pretty good first draft of sort of what that island looks like. Now, I still prefer, that as a one-click option. That shaded relief is pretty easy, and again, that's under Analysis, Raster Functions, and then Surface. You'll find shaded relief. So as a one-click option, I do really, really like that quite a bit. But if you want to have a little bit more control over how this appears, then you can change the symbology like we talked about. Choose something that makes sense for your data. You're going to have to find one that you think makes sense, but this seems okay. And then you can go in and run that hillshade. And the reason that the multi-directional hillshade is actually a little bit better is because the neutral slopes, zero slope effectively gets a whitish color. And that helps with the layer blending. It's not that you can't do it the other way, but it tends to work a little bit better this way. And again, if you wanted to sort of bring out that detail, you could have a slightly higher Z factor here to add some vertical exaggeration to that. You always have to remember to check your layer. So a little bit more definition as you increase that Z factor to sort of bring out some of the details. And again, the way to do this would be to take the layer blending and to turn that to multiply. And then what you get is sort of, you get the benefits of your hypsometric shade, but then enhanced a little bit with the shading that comes with it. So I happen to like this a lot. You may decide that it's not for you. Okay, so let's talk just a little bit about you had a DEM of difference that you had calculated, which was great. I loved that in the presentation. When I say, this is sort of often talked about in a cartography class, but may not get, if it doesn't come up often, it's easy to sort of gloss past here. But so sequential color scheme is sort of going to go from, one color through a number of other colors. So in this case, oftentimes greens to yellows to browns. They got a little bit of white going on here at the ends. A diverging color scheme is going to be one that typically has sort of a neutral color in the middle. So this would be a good example of a fairly neutral color scheme in the middle, kind of a yellow, and then it goes to red over here and blue. And there are lots of ways to do that. So if you look through the list here, this sort of brown to green would be a good one. This would be a little bit more colorblind friendly, which is often kind of a nice thing to do. But a lot of these, this is a diverging color scheme. It goes from this orange into kind of a neutral color white to purple. And so the value of that, and I'll come back here to the eTopo1, is that you can start to see highs and lows. So we'll just use this brown to green. I don't, this seems maybe not quite the direction I would want to go, so you can invert that if you wanted to make the kind of aqua color a little bit more for the water, which I think makes some sense. Now, the thing that you want to do with a color scheme like this is to make sure that it's zeroed the way that you like it. So what it's going to do by default is sort of use these percent clips or maximum and minimum, and what you really want to do is control where those breakpoints are. Ideally, because your zero value here is a significant thing, right? Your zero value in this case corresponds to the mean sea level. So you really want this thing to be symmetric about zero, which it's not, right? It goes to negative 10,000 to positive 8,000, so it's not symmetric at all, and that's why these coastal areas don't look quite right. So if you wanted to change that, you can define these in a way that you like. Now, oftentimes it's nice to have these numbers represent something that is significant. In this case, I'm not going to do that because a lot of times you're just going to try to bring out some detail. But what these numbers are might actually really matter a lot to you. But in this case, I'm just centering it at 10,000 plus and minus. You could center it at 5,000, which is going to enhance the contrast a little bit. So what these numbers are going to change the final appearance. And you can, of course, add the depth, the shading to add a little bit of depth, which looks a little bit nice here. So the lesson here is, choose a diverging color scheme for your DEM of difference. There are plenty of these in here. You're looking for one that has kind of a neutral color in the middle and then a color on each end. It's nice to choose one that is colorblind friendly. So a lot of times something like blue on one end and red on the other hand is not very colorblind friendly, but orange to purple is. And then make sure that you're choosing values here that are symmetric about zero, so that your neutral color would correspond to kind of no erosion or deposition, and then positive and negative works out the way that you'd like. I don't have a DEM of difference. I was looking real quick to see if I could find one, but I don't have anything laying around. So so eTopo1 is a pretty good start. I hope that outlines the idea that I had. I know sometimes, I mentioned something at one of these meetings and it may be hard to see how it gets implemented. So I just wanted to record a little bit for you to kind of walk you through what that would look like. Really enjoyed the thesis and the presentation. They were great. If you have any questions about this or anything else, I'd be happy to answer them. And stay in touch. All right, take care. Bye.